Okay, to solve a rational inequality, no, not irrational, rational inequalities, okay? Here we go. Well, the first thing we want to do is set it equal to 0. So how would I set that? Well, not equal to 0, but set one side where it's 0. Instead of I have that 3 there, I would probably minus a 3 from each side by writing it in what we call general form. But what I need to do now is this here. In order to add that, I really need a common denominator. So what I'm going to have to do is this. See that minus 3? And what's my denominator here? It's x minus 5. So I'm going to have to write it as a single fraction and multiply x minus 5 over x minus 5 to get a common denominator, which means I'll take negative 3 times x and negative 3 times negative 5, which is why I end up with negative 3x plus 15 all over x minus 5. Now I can simplify by combining terms. The thing is here, 2x minus 3x will be a negative x, and negative 7 plus 15 will be 8. And notice this is less than or equal to what? 0. I have to have the one side set to 0. And now what I'm going to do is this, and if you watch the part about the zeros, right, let's go talk about that. This is where the zeros come in, all right? Right here, the zeros are the values of the rational expression. We're going to set the x values, the numerator 0, and we're going to set the denominator equal to 0 to see where it's also undefined, because the only time you can change from a positive to a negative is at what we call these zeros. All right? So I can only change to positive and negative, and there's a 0. So set the numerator to 0, negative x plus 8 equals 0, and the denominator to 0, x minus 5 equals 0. So x equals 8, x equals 5. All right? So this is where it can change from positive to negative, only at these places right here. So what we're going to do is the following. All right, I got my little number line here, and what I'm going to do is here, notice I have a 5 and an 8, kind of got a 0 there to know where it's at. And here's what I'm going to do. First off, look here, I know 5 is a possible solution, either going to be left or right of it, but it can't equal 5 because why? 5 is in the denominator, so it cannot equal 5 as an answer, because if I have 5 minus 5, I get 0. I also know I have an answer at 8. It can be left or right of it as possible solutions, but notice, can it equal 8? Yes, it can. So I know that one's going to be colored in. I already kind of know that part of it. I just don't know whether my graphs go out or whether they're colored in. So here's how I find out. I'm going to pick a number left of 5. Now I'm going to pick 0 because that's an easy number to work with. I'm picking the first number larger than 5, because that'll be an easy one. And I'm going to pick 9, the first number larger than 8, to test where these values work. And basically we're going to find these intervals. See, anything between negative infinity and 5 will be here. And I picked 0 because that's an easier number. So I'm going to put 0 in this number right here where it says plug it in this equation. All right. And I'm also going to do 5 and 8, and then pick 6 between 5 and 8. Notice 8 is a bracket because it can equal 8 possibly. I don't know if this is right or not. We're going to test it and see. And then we're also from 8 to 0, 8 to infinity. I picked 9. So I'm going to plug these numbers in. Okay. Now I put a 0 in here. Well, that's going to give me 8 over negative 5, which means my answer is a negative. I don't necessarily need to know exactly what it is. I just need to know that it's negative. Now, look up here. I am looking for values that are less than 0, so therefore I know that those values are good. Any number here will work for my solution. So let's test 6 by plugging it in. So notice I have negative 6 plus 8 and 6 minus 5. That gives me 2 over 1, which is positive. Now look at my answer. I'm looking for values less than 0, so therefore 6 is not an answer, so I know I'm not going to be graphed in here. So let's look and see if 9 is an answer. So I go in here and I plug in the 9, and I take negative 9 plus 8. Well, that's going to be negative 1 over 9 minus 5 is 4. Well, that's a negative. And notice I do need values that are negative. So that's what I have. So I know that these are the values that are good. Everything less than 5 and greater or greater than 9. So these are the values that work, and the way I write the answer is this here. It's an or because they can't be in both of those. So if this is true, it's correct, or if it's true there, so that's the symbol of a union. And notice 8 is a possible answer, but 5 is not. Hence, that's why this is written with the parentheses right up here. Okay, and then we have the 8 right there. That is our solution to this rational inequality.